moving on to integrated products.
Yeah, so,
Okay, I wanted to bring up about the snow depth, and is there, maybe there'll be an opportunity to talk to.
you could, no,
Go ahead,
bring it up.
bring it up now,
Is, I, saw a presentation from the NRCS first a couple weeks ago, and did you know that there are, snow depth stations, throughout Alaska? And I looked at the spreadsheet real quick, and it appears that the snow depth is for that, just that one point at that station, right?
Yeah.
But would it be possible, just like with climatic stations, to try to maybe interpolate between, especially if you were using like NOAA, satellite data, which they also have something for, the, satellites that pass over every day, you know, with like 500 meter or 1 kilometer resolution. Do you think it'd be possible to try to combine the two to do some kind of interpolation?
Yeah, I know there's been efforts elsewhere to try to do that. I know they desperately try to get at that, say like in the Sierra Nevadas and the Rockies, actually estimate just how much snow water equivalent there would be and correlate that to snow depth and how that movement. And Nancy touched on this just a little bit yesterday, but snow depth really has a lot to do more than just climatic variables, more than just topographical, but some of the wind patterns and the micro kind of scale processes that would determine actual snow depth. So we can get at things like snow water equivalent, we can get at things like how much snow is actually falling, but accumulating on that landscape it's a science in progress for sure. I think there's a lot of people interested in it though, and I know there's even been efforts in the state to kind of look at it and look at proxies for snow depth. So it's coming, but it's still just very much a huge data gap. But I think there's opportunity.
A team working on it for the North Slope. I forget what
Yeah,
institute they're out of. I mean, it was a huge effort.
in Colorado,
Yeah.
on it.
Exactly.
But, I think one of the limiting factors for interior Alaska in general is the limited number of snow-tell
Yeah.
sites.
Yeah.
And so being able to interpolate across that.
Right. Yeah. There's less no-tell sites than there are even climatic sites, which are just basic climate sites. So, yeah, it'd be hard to interpolate anything meaningful across the broader landscape, but it's certainly a resource that's useful and something we could probably stand to have more of.
So, you know, NASA's putting up that satellite in a couple of years, the soil moisture satellite, and I think that has microwave on it, right?
It does, yeah.
Is microwave helpful when looking at snow depth?
You know,
It will penetrate or not
I think
really?
it is. You know, I'm trying to remember, because I was thinking about that. They mostly use it to penetrate the ground surface to get at soil moisture content, right?
Yeah.
And I know it's you know, like any other thing, kind of scatters based on the size of the particles and whatnot. So, yeah, I'd have to look into it more. I think there are.
That might be something, they're gonna come up and do a workshop this winter, talk about all
Yeah.
this stuff, so that might be a good thing to talk to them about.
And actually now I'm sort of remembering, I went to this remote sensing workshop sponsored by the NSSI, and I think there is a physicist up at UAF that's looking at the possible application of microwave technology to get at snow depth. I think I remember that now, so, yeah, some opportunities for sure.
Because I think that's daily, right?
It is, yeah, I mean, that's gonna
One
be
to stop.
huge resource, yeah, exactly. Well, I'm assuming it can get through all of our atmospheric issues too, but,
Right.
yeah.
Hopefully we can find a rocket engine to launch it.
Yeah.
Yeah, exactly. So, yeah, I just want to kind of run through some of the integrated products again and give a little bit more information about how they've developed and more targeted applications of these data sets. You've gotten a good survey, I think, of all the baseline change agent and conservation element data sets, and really the highlight is on the baseline aspect. You know, a lot of these things just didn't even exist prior to it. And so this is that next step of taking that baseline information, trying to put it together to make some meaningful interpretation of, you know, conditions and how those might change and really what is likely to initiate a management response. So just to remind you what we consider integrated product analyses or products, it's all these kind of change agents interacting with the conservation elements, coming together in different kinds of products, and I'll go into more of the details on how we develop landscape integrity, looking at the landscape condition model plus intactness, and then the cumulative impacts. And I'll throw in a teaser slide of what you might be able to do with conservation elements status, just to get the brain juices going, maybe. So the landscape condition model, if you remember from our methods webinars a year ago or so, basically takes the idea of human footprint and assigns a site impact score and a distance decay score. So site impact estimates the relative impact of that activity on the landscape. This is irrespective of any specific species response or habitat response. This is just, and it's based on thousands and thousands of literature review out there, and experts as well, summarized for the kind of relative impact that any given activity. And I'll say the landscape condition model is actually something that was developed by NatureServe. It's been applied in other REAs, certainly the Seward Peninsula, which is partially why we adopted it for this REA as well. But they are doing it nationally, and the Western Governors Association has signed on to use the landscape condition model as their metric for landscape integrity for the contiguous western U.S. So it's actually a pretty well-accepted approach to understanding overall landscape condition. But we had to modify it because what goes in the lower 48 doesn't go for up here, especially for understanding impacts or the nature of roads and how people use these different kind of infrastructure. So this gives you just a real quick idea, and there's more details in the memo, but this gives you an idea of some of the data inputs that go into it, the relative impact. So the lower the score, the greater the impact there is. So the lower the score, the lower condition would be, bad for the environment generally, and higher scores mean that there's less of an impact. And you can see how the distance decay varies. And so for a landscape condition model, we assume just kind of a linear distance decay. There are some other ways where you can model this, but we're pretty much saying from the point of the activity to that decay distance, that area of influence, we're just going to gradually decrease that impact until it peters out to nothing. And you'll see what this looks like in a GIS. So we look at all the...
Amy, were all these classes present in the RIA area? So you guys had a road you called the primary highway, and you had a road called the haul road?
Yeah. So these themes or whatnot are taken from the landscape condition model, and then our description kind of describes how we, what the data set we're using, how we translated it into. So that primary highway, obviously we don't have highways in the region, but we do have what DOT calls a secondary road. It's only a tiny little slice of the study area, but we do have a couple of secondary roads that receive vehicle traffic, regular vehicle traffic. So we found that was pretty analogous to what they were calling a limited access highway. This is also, and there's more details in the memo, but this is also based on research that has been done on the effects of road ecology in fragmenting the landscape, even in Alaska. So Stritholt and folks have done, from the Conservation Biology Institute, done some assessments of intactness up here, and they've kind of got these empirical estimates of the relative influence of roads on the landscape. So we also looked at, what they call urban and industrial development. We've taken from, digitized urban footprints to historic and current mines, oil, gas wells, and that sort of thing, plus invasive species. And so all of this is put together.
Hey, I'm sorry, can you go back to that slide?
Yeah.
This is not pertinent for our area because we don't have this, but we just recently saw an article about the effects of transmission power lines, not local power lines, but long-distance power lines on caribou, because of discharges. They discharge in the ultraviolet range, the IR range maybe, I don't remember which. Anyway, a range that people can't see, but caribou can see, that deterred caribou from crossing. It wasn't caribou actually because it was Europe, so reindeer, crossing power lines, and it was like 2 to 3 kilometers.
Wow.
Of distance, which we don't really have here. I mean, if they did end up putting in the pipeline, and not put the gas into the villages, but build a power line and then put industrial, it could affect there. But I'm thinking for some of the other RIAs, as you guys go forward, there may be places where we might actually be putting in industrial power lines, and that might be something to look at. And I passed that article on to Bruce, I don't know if anyone else has read it.
Yeah, no, if you'd
But it
be
was
willing to
pretty
pass it on, that would be really good.
interesting, so maybe if we could, Elisa, could you make a note to ask Bruce to pass that link on to these guys?
Okay, yeah.
Yeah, that'd be really great. Yeah,
But it was
especially
pretty
if that-
interesting.
Yeah, that information becomes more and more available.
Yeah.
You know, you'll see this in my data capture, there's not an awful lot that links to species responses to the tutorial system.
Yeah.
So it's a big limitation, but this is, you know, a general composite of how things respond in a very general sense. I know power lines will not make a huge difference for sage-grouse, because the raptors concentrate on them when they hunt them out. So they're really bad for specific types of species, definitely. And I think in future RAs, you know, when possible, we desperately tried for this RA, to identify specific species responses to each of these elements and modify the landscape condition model for them to establish their status, and the information just wasn't available for this RA, but,
Well, I'm
we
not
hope in
sure
the
this
future.
area has any of the kind of power lines that we're talking about anyway at this point, so.
Exactly, right. But we look forward to the North Slope,
Yeah.
because there's been some really good work on things that influence the pipeline and caribou movement and that sort of thing. And,
Yeah.
so we'll be able to do that a little bit more explicitly.
Just a reminder for folks to mute their phones.
So this just gives an idea, you know, we put these all together, to get this idea of a comprehensive, human footprint, and then, you know, the area of influence that human footprint has on the broader region. And this is what it looks like, when taken in a whole, and you've kind of seen that at that scale, so I decided we should zoom in and just see how that distance decay kind of, plays out, and granted, these are bracketed into the categories of very high, medium, and so on. But you can see just how the impact of a secondary road has on the larger landscape. The trails, it's a very localized kind of impact, according to the model, as well as villages having an impact.
So it looks like the green are the trails, is that what?
Exactly, yeah, so that kind of corresponds to still a high condition, right, because even at the very central location of the trail, it's still not degrading the condition very much. Most species can move across it, they're not really fussed by it, but maybe other kinds, and again, we bracketed by the different kind of four-wheel drive trails versus just footpath trails, if we could differentiate it. Those old tractor trails were all kind of treated, differently, just based on whatever we could find in the literature on the nature of those impacts.
And the yellow ones, more like the roads.
Yeah. Or more formalized trails. I mean, just an awful lot of those old tractor trails, an awful lot of four-wheel drive type trails through here. And so that's most of the spaghetti lines that we're seeing. So this is out flat, you can kind of see the differential impact of I think, a mine versus, you know, invasive species, you know. So just these little bubbles throughout the landscape of where an impact is counted and how that degrades over the distances.
Are any rivers that are navigable included in this?
You know, we tried. We wanted to, but no, it's not. Unless it's identified as a snow machine trail or something for wintertime, we didn't, and we struggled an awful lot about those seasonal use kind of transportation corridors, and we just don't have a good way of knowing the impact at this point. You know, I looked at snow machine use on, there's some studies in Yellowstone, an occasional study from places in the western U.S., and it's just not clear on the impact of snow machine use or intensity of wintertime activities on species and stuff. We stayed away from it in this one. Hopefully, as more information becomes available, we'll be able to do it, because it became very apparent that they used the major river corridors as primary transportation corridors during the wintertime. There's no evidence out there to really quantify that impact, so we had to leave it out.
Well, now, going back to the trails, talking about seasonal, a lot of the trails that we took trails in our land use planning area are winter trails.
Absolutely, right.
So are these all-season trails?
These are all-season trails. I don't think we included any wintertime trails. Anything that was seasonally bracketed, realizing that some of them aren't accessible because during spring thaw, it becomes just a boggy mess, and you can't really cross it anyway until later summer dries it out. But anything that has some specific seasonal component, we tend
your only secondary road, the road to Ophir? I'm trying to, it doesn't look like it.
I don't know,
Two foot
yeah,
crosses.
yeah. Yeah, we did our best to QAQC that DOT transportation layer. Again, it's a data gap, in my opinion, because it's just not well. A lot of the local community map, roads are not mapped well in that data set. And there's just some spurious lines in the middle of kind of nowhere, where I couldn't really identify any specific impact whatsoever. So I'm not sure where the lines came from, and we did our best to kind of remove those. So we did this for current condition, obviously, and then based on future anthropogenic footprint forecasts and best case estimate or best guess estimates, we modeled it into the future as well. And so you can kind of see where the road to Nome kind of gets picked up there in the near term, and certainly the pipeline possibility, and then the road to Kuskokwim. Overall, the condition doesn't get degraded all that much regionally. And we've seen this through all the CE statuses, obviously, and it's just holds very true for the region at large. When we summarize at the 5th level HUC, we just see complete intactness, really. I mean, just a few watersheds that kind of increase their level of human activity and go from very high to high condition, what we consider high. So really pretty solidly intact. We saw this yesterday too, but just to remind you, pretty much everybody's doing real well in that very high condition. But there are some land managers that are faced with slightly degraded landscapes, and I did put up the percentages now for you, at least in this table. I don't know if I copied it over the other table, but at least to give you an idea. So POD is, in fact, a very, very teeny tiny slice of the landscape. Still super intense impact on that teeny tiny little piece of landscape. And it is a possibility of looking at for sort of the cumulative effects or the surrounding effects from the intensity, because I know a lot of those DOD sites end up being super funds and having a larger contamination area.
So in general, were those DOD sites identified as human development areas, degraded human development, and on the human development map?
Yeah,
Okay.
Exactly. Yeah, they're either digitized as some sort of human development footprint, or have enough roads or other kind of things that Cumulative landed up to a degraded landscape.
And I guess a similar for, sorry, to go back to the native corporation land, I mean, basically all the villages, that's where all the villages are, so that's where all the human footprint is. So it's most of this stuff that's in the very low and low that's on the corporation land is probably the villages themselves.
Probably just the villages themselves,
For the most part.
Yeah, exactly.
All right, thanks.
No problem. So some of the applications of the LCM, obviously, we have good opportunities to set up monitoring and management of resources based on a baseline pristine condition. I mean, this is a luxury that the lower 48 does not have, just like Tracy said. You're not going to see this kind of distribution anywhere else. So we have a reference condition. We don't have to come up with some hypothesized reference condition. We have a reference condition, and we have something that we can measure from baseline forward. So we have a really good opportunity to develop monitoring and management opportunities there. We can also develop policies that take into account this high condition. And this is what spurred Karen's topic at the Landscape Ecology Conference. How do we break these landscapes more smartly? If we've got a nice intact landscape with super high condition, how do we choose land uses and activities that don't degrade that overall condition to the point where we've got a broken landscape? And the other real advantage of LCM and the application, I think, is that it's quickly repeatable. I mean, really, it's just a few GIS data sets. We've got the parameters built in. It's going to be really easy to do scenarios of different kind of road locations or any other kind of human footprint derived scenarios where you can run it real quick to see what the overall impact on the landscape condition would be. So this becomes a really useful tool, I think, for just exploring the possible impacts of future land use decisions on the ecoregion. There are some obvious limitations and data gaps beyond, what we've kind of talked about before, and we did talk about this idea of just, how sensitive are boreal systems, and, that the landscape condition model is a generic estimate of impact. So, the impact of a road on a wetland is different than the impact on a road on a tundra land cover. So taking that into account in more focused or more, smaller scale kind of assessments is going to be really important. But obviously for the broader ecoregion, it provides a nice tool for assessing overall condition. Data gaps, we've talked about this, human footprint. We'd love to have more empirical data from Alaska, partially to get at that sensitivity of boreal systems, but also just to understand at what point does the condition get degraded, that we start seeing responses or degradation from the reference condition. And, you know, we need, and this is not just a scientific endeavor, scientific data gap, but we need to understand what are the ramifications from going from very high to high. Are they different from going from medium than going medium to low? Is that an important threshold that we cross? How do we define that threshold? What's important for resource managers, what's important for the public, and what's important for the ecosystem resources? So I think that's a really important data gap to identify, because everybody's really interested in this idea of landscape condition and overall maintenance of landscape functionality and ecosystem services, and all this hinges on our ability to say, at what point do we break it? At what point is it not pristine? At what point does it stop its function or degrade the condition? Part of the way we can get at, you know, sort of the cumulative idea of landscape condition and how it might be impacting ecosystem services or functions is to look at, you know, CE status. And you've seen a lot of this where we're just looking at the distribution of the CE and overlaying it with landscape condition and quantifying it. Here's the floodplains, and we see that it's still very, very, very intact. But if you summarize this, say at the 5th level HUC, this is the teaser, and you do this for all the conservation elements, where we've selected all the conservation elements to specifically identify key ecosystem resources. So when taken together, if all those systems are working well, they're all high condition, we would expect good ecosystem integrity, right? If we know that all the coarse filter systems are high condition, we know all the fine filter species are in high condition, we can say this ecoregion is good, it's really solid, it's functioning, it's integrity. And so this is the teaser. I've done this for the current. It's an awful lot of GIS processing, so we're not delivering this, but I want to give this as an idea of applications for the landscape condition model and these CE statuses, that you can actually boil this up and look at HUC by HUC. Okay, if 15 out of the 18 conservation elements are in this HUC, and they're all really high condition, then that's the highest integrity. But if 15 of the 18 conservation elements are in another HUC, and they all have just a slightly degraded condition, then that's the lower integrity. And you can see the kind of gradients. The reds are the lower condition, and the greens are the higher condition. And just so looking at sort of the species richness, or CE richness, if you will, and overlaying that with the landscape condition model, it kind of weights it. So it says, okay, if these ecologically relevant species and habitats are all co-located in these areas, those are probably the areas we want to focus on most. And especially if the condition is degraded across all those species, we want to focus on those areas the most. So it's a teaser, an idea to pursue further with this kind of data set, especially as we identify more specific ways in which condition impacts species.
Can you go back to that for a second?
Yeah.
Have you thought about how we figure out what that threshold is? Is it very high to high? Is it high to moderate? Because, well, right. I mean, how are we going to figure that out? Because, I mean, that's really pertinent, I think, to something like this, because, when you start to turn from light green to white and to light orange, the implication is that visually, at least, is you're crossing some threshold, right?
Right, exactly.
And so is this, if you don't know where that threshold is, how do we know that the white is white and not a lighter shade of green? You know what I mean?
Yeah, no, absolutely. Yeah, you don't know. Yeah. It's the cursing and the blessing of
Right.
GIS, right, is that we can tell you a whole bunch of stuff, that means nothing, or we can lie an awful lot with maps, right?
I don't think it means nothing. I mean, it means, it points out areas where we want, maybe want to pay more attention, but it doesn't.
It requires interpretation before it has meaning.
Yeah.
It requires substantial consideration before it has, authentic meaning. Yeah, it's just data at this point.
Right.
It's just data.
So how do we start figuring out this threshold then?
Yeah, in my landscape ecology conference, I'm like, this is the holy grail of landscape ecology, right? We can figure out how to quantify the breaking point for ecosystems and the landscape, boy, we're set, you know, you've got a career. Don't have to worry. 10-year everything. Right?
Yeah.
It's hard, and you know, there's a lot of good literature out there that talks about, you know, you really have to consider the context. You have to, that's why these ecoregional assessments are nice, because it's putting it in a meaningful geography. You know, because obviously landscape conditions here means nothing relative to landscape condition down there in the lower 48. I mean, that's two different kind of systems. And so, it requires careful consideration of local context, local resources, and ultimately, what's that?
It depends on what you're trying to
And
preserve,
it ultimately just comes down to, it comes down to the
integrity of the evolution of the species.
Right.
I mean, they've been studying that where they say that set aside 50% of the landscape.
Right.
Exactly.
Right, well,
And public need.
Yeah.
You know, ultimately, this is a policy decision over a scientific.
Yeah.
Yeah, at what point do we care that the system becomes degraded? And can we quantify that? We can quantify probably any number of ways, socially, environmentally, politically, right?
Yeah.
You know, in this example, are we looking at vector data or raster data?
Raster, summarize the HUC.
Oh, that's right. So, would it be possible to go back a step and look at it a little more raw, like pixel by pixel, so that you could at least, it's the model itself or your pixel size that has defined the threshold.
Right.
So at least we could see the original raw.
Absolutely.
Data.
Yeah, but you'll have access to all that data actually once it comes online. We're sending it both in the raw pixel as well as the summarized HUC, with the caveat that the raw pixels are you know, should be interpreted at a larger scale, you know, not at the pixel by pixel, because heaven knows our data is not clean enough to do that. And this is all 60 meter, I should say, because even though veg stuff is mapped at the 30 EMs, are still 60 meters. So pretty much everything has to at least come up to that level.
And then what's the value on a pixel? Is it a percent or, you know, your
Relative,
index?
yeah, it's just that relative condition score, yeah.
Okay.
So it goes from 0 to 1.
Okay, so
Yep.
it's almost like a percent.
It's kind of a percent, yeah. I mean, it's a normalized scale to just get a relative idea of the level of impact or condition.
Okay.
Yeah, John?
In the products that you're providing, are you gonna clarify what it was that you ran at the statewide scale, and then what you couldn't run at the statewide scale for everything you looked at, or did you, in fact, have everything at the state?
Yeah, no, we won't provide anything at the statewide scale, actually. We're required to clip everything to the REA boundary.
I know, I'm just wondering if we get the data, I can then use my RMP boundary, because it's got most of the planning area except for 7th to Shaktoolik, hugging the Norton Sound. That's most of the BLM land.
It's true. So, yeah, I mean, in some cases, when we do have the statewide data set, we are delivering that because part of the processing steps that we have to show is how we clipped to the REA. So where there is a statewide data set, you'll be able to, take that data and clip it to your new data set.
I think maybe after we're done though offline, it might help to talk a little bit about the Seward Pen, the compatibility of Seward Pen and YKL, because you guys might be able to give us some insight there, I think. Because you guys looked at some of that a little bit, right? Haven't you been trying to help a little bit with that? Or maybe not? Anyway, maybe we can have a side conversation after we're done here, but before we all done.
How far did the Seward Pen go south there? Did it go as far as Uniclete? No? Okay.
Oh.
I think we did, yeah. I think
All of
the
it
Seward
was
Pen.
Yeah. All of it.
So, anyway, let's not get.
And we have a 1 HUC 5 buffer around so that they overlap, the Seward Pen and the YKL overlap by that 1 HUC buffer.
Another thing I think that, you know, in terms of breaking it out, like if we see a particular watershed is one of the big impacts of, say, placer mining, then what that might tell us is that we might want to focus on restoration efforts there, or whoever the land manager is of the areas that are affected by placer mining that might be a priority for action to move the color of that puck.
Right.
But some of them, I mean, the impact is villages. It's
It's just the
it's people living on the
Exactly.
landscape, there's not much we're gonna do about those. But some of these are things where we may actually be able to take management action too.
Right, right. Especially ones where we're forecasting some Lowland change, either in the human footprint or otherwise.
That's interesting to me that there's a lot of the population centers that don't show up as these, and now that's probably because the CE distributions don't overlap with the population centers.
Exactly.
So, the reason that those CEs don't overlap with population centers is because they've already been lost from those areas.
Or they avoid, yeah.
Or they just avoid,
Or they
right,
avoid.
right. Yeah, right. Yeah. It's good conceptual discussion, right? I mean, it's really, I think some good opportunities for future, thoughts and research. So, I presented briefly on landscape integrity, and again, this is a derived product from the landscape condition model. Another way to kind of look at condition and understanding it in the broader landscape is what landscape ecologists like to do most is break it into blocks, right? Give us an idea of how contiguous a landscape is, and assess that whole concept of fragmentation, right? Look at how fragmented a landscape is. And it's important because, you know, we need to assess the condition within some regional context. We need to know, well, just because we have high condition scores, are they connected to each other? If they're totally isolated from each other in a random kind of placement, that doesn't do the landscape any good. But if they're connected, if they're all together in big blocks, then that's really good, and that applies some element of stability, because then you have that ability to perhaps resist change or be resilient to change. And so we looked at large intact blocks. We broke the landscape up based on those with just that very high condition score, which, by the way, in the lower 48 doesn't even exist in national parks. Only a few wilderness areas have that high of a condition score, so we're kind of the cream of the crop, top of the top, right? So you can break this up in any number of ways. And then we grouped them into areas based on different classifications. And so the Global Forest Watch program, part of the World Resources Institute, has come up here and done an assessment on forest intactness, and they recommend at least 50,000 acres as being, you know, really good intact landscape or contiguous areas for resisting change or being resilient to change. And so any area with greater than 50,000 acres and that high condition score, we say that's the highest integrity we can expect. That's the highest integrity landscape. That's going to be the most resilient as far as we can tell. But we didn't want to just degrade, you know, just say over 50,000, because there's certainly been cases made for wilderness designations. There's a study done on BLM lands even for wilderness designations that said any kind of areas with high condition over 10,000 acres should be considered for wilderness designation. So we kind of consider those the high condition or high integrity. So less than 50,000, but greater than 10,000 acres. And then less than 10,000 acres we identify as vulnerable. So those are the patches that we're saying, well, if some catastrophic event or some human land use kind of came through, this would potentially be a vulnerable patch of habitat, vulnerable patch of landscape. So it's still a high condition, so it's still those really high condition values. So these are the patches that you'd be most interested in watching for those impacts. And then we have the lower landscape integrity areas that kind of vary in size. And so this is what it looks like. The lower landscape areas are just not included. They're the white areas. But we see mostly, obviously, the highest level of integrity across the landscape. I'll show the percentages in just a minute. You can see some fragmented areas that are still considered high. There's still over 10,000 acres, so those are still high integrity areas. But you do see some fragmented pieces, and those become important, especially if you consider, you know, maybe subsistence use areas or other kind of natural resource use in locations where this fragmented landscape happens to be. Could have important implications at the but this is just at the ecoregional scale. And we model this into the future too. Since we have a landscape condition model going into the future, we can break up the landscape according to it. And we see slight degradation in the highest, definitely an increase in the non-intact. Vulnerable stays pretty much the same, identical. So as of 2060, we're not really seeing too much localized land use in those vulnerable patches. But this doesn't take into account the other change agents, which I'll talk about in a second. So this is how it lays out numerically, just, obviously still super high intactness and integrity, but you do see an increase in that lower landscape integrity metric. Some of the implications, again, how do we break the landscape smartly? We can develop policies that take into account the already high integrity, and we can look to monitor those vulnerable areas, especially if we relate this to other information in the RA, like subsistence use areas or other culturally relevant places. And we can, I think, ultimately use this to help us at least make those initial steps at looking at connectivity for important species. And so the caribou migration was a question that we desperately wanted to answer. And this could have laid into, how connected are the patches that the caribou use. And so it's not something we could address, but it's certainly something in the future that now that we've broken the landscape up into these contiguous areas of high condition, we would have an idea of just how accessible the landscape is to different creatures, how easy it is to move across that landscape. Any questions on any of that? Some of the same limitations and data gaps exist for the integrity, although to go that extra step and call it integrity, it does assume certain things like that the only important human impact is the one that's visible on the landscape. It totally ignores the idea of atmospheric deposition or any other kind of changes that aren't physically evident on the landscape. That's a big assumption, actually. Something that we in Alaska should probably really consider, given where we are in the polar circulation and given the fact that we just kind of assume everything's super intact and fine. And it also ignores past land uses, and we desperately try to include historical mines because they're still on the landscape, but it doesn't include anything about traditional use areas. It doesn't include anything about, what the military may have done back in their territory, stuff that was unmapped, that we really have no idea. And so just because the physical imprint isn't there now or it's not mapped now doesn't mean it didn't have an influence. Again, species may be responding to things that happened 30, 40, 50, 60, 70 years ago. So just some of the limitations and assumptions, and then of course the same data gaps. So the last piece is this cumulative impacts model assessment that we did, and this is a big, ugly conceptual model or process model, but it gives you an idea, and this is in the report. You can go through it step by step, and I'll do my best with bullets, but just how we took different metrics, all these 7 different metrics of the change agents, applied some thresholds and looked at them cumulatively to give an idea of just where those hucks that are going to be most impacted are likely to be. And so I'll step through them here. Mean January temperature was looked at, mean July temperature was looked at. We used 1 degree threshold as being important because we already have good evidence that 1 degree has led to changes in ecosystems in the Arctic. This was an Arctic paper that identified that threshold, so we gave it an impact value of 1. And we said greater than 2, which is kind of the scientific standard for like catastrophic changes. Again, this is kind of the rest of the world where 2 degrees C is on their upper limit, not the Arctic. They say that's going to be significant changes to ecosystems. And there's some articles even in the Arctic that suggest the same thing. So we kind of gave that an impact value of 2. So we did this for both temperatures, although there's no 2 degree increase in July temperature, so just an impact value of 1 there. And I did my best to just keep it all consistent, because I don't want to say that the climate is more important than permafrost, or permafrost is more important than fire. So I just did blanket impact the value of 1 for all these impacts, except for that 2 degree climate change, because that's sort of the 800-pound gorilla, or the 2 degree temperature change. So mean annual precipitation shows a threshold of 50 millimeters, because that's about 10% of the forecasted change, maximum forecasted change. And so that's a pretty significant change in precip. Hydrologically, we saw from the that's well above that sort of threshold, so, we identified hucks with a value of 1 there. Any hucks with permafrost areas that are changing from continuous to discontinuous in greater than 20 square kilometers, so a significant portion of the huck, we said that's probably going to have an impact on the huck. It's probably a change agent you want to monitor. That's an impact value of 1. And then fire frequency, 10%, greater than 10% increase in fire frequency. Again, we're not saying 10% of the landscape, we're just saying 10% increase in that fire frequency would be an impact value of 1. And then finally, any kind of change in the landscape condition or invasive species vulnerability, we said that's a huck you want to monitor. And when you put it together, you get these maps, these cumulative impacts or kind of conversely vulnerability hucks. And you see in the near term that it's pretty small changes, or just 1 or 2 kind of change agents acting on any given huck, except for around the Galena area. But certainly in the long term, that whole northern swamp is forecasted to see multiple change agents changing above those thresholds, above potentially meaningful thresholds. And so you break it out, there's the near-term kind of impacts, and then they shift over to, a higher cumulative score in the long term. Again, we broke it down by the land managers, and we do see some differential responsibility or differential need for responses to these cumulative impacts. Both federal, state, tribal lands all have some significant areas that's likely to experience these high degrees of change. So the applications here, again, super useful for monitoring programs, especially the areas where we expect to change the most. The inverse can be used as landscape vulnerability index. It's been something that's been thrown out in the literature as potentially, crucial for climate change mitigation or climate change adaptation plans, is looking at landscape vulnerability. So the inverse could be really useful, especially if you're looking at potential ACECs or other kind of conservation designated areas. It can be used as a collaborative planning tool because, nobody's isolated. You're all in the same boat. All the land managers are kind of facing the same real types. Some were worse than others, but you're all facing the same kind of cumulative changes. And so there's some important opportunities to kind of come together and start monitoring these shared hucks and understand the response.
Jamie, was
Do you
that,
break down,
the units were square kilometers in the last slide?
Yes. Yep. Square
my
kilometers.
question was, do you break down in this section which of those impacts plays the bigger role in the cumulative impacts? Whether it's temperature or permafrost, or, which of those plays a bigger role?
No, we don't, but all the data is there for it. If you wanted to tease it apart, it's pretty easy to tease apart. Yeah. Yeah, so some of the limitations are that, this doesn't assume, or this doesn't even address any of the possible feedbacks or the interactions between the change agents. And that's likely to be even more important. Just stacking them on top and saying, okay, all these change agents are going to happen. Now that's one thing, but how all those things are going to interact is a whole different beast. How the landscape is going to respond is a whole different beast. And it's something that everybody's, I think, really anxious to get on, and that's why the integrated ecosystem model is receiving a lot of good funding, because we need to understand these feedbacks. And another important limitation is just that these thresholds are not well defined. These are conceptual ideas that have been tossed out and occasionally cited with some empirical data, but really we have no idea what's an important change. So same concept with the landscape integrity. At what point does a change in precipitation trigger a management decision? Or at what point does change in precipitation trigger an ecosystem response? Or social response? What point is important? And it likely varies a lot, but it's something that needs to be defined at least at some meaningful scale. And the other caveat, I'll just throw it out, is that multidisciplinary modeling is awfully tricky. These are all models that were developed independently. for the most part, of themselves, of each other, and so when we're putting them together, we're kind of propagating whatever errors or assumptions or limitations are in each of them. So, just a caveat to add, multidisciplinary modeling is always really, really tricky. But the data gap, again, is understanding the important thresholds, persistent dynamics, and planning actions. So understanding both that these thresholds don't exist only scientifically, but also socially and politically. And that's actually something really important to consider when doing these kind of models for this kind of scale of analysis is how do we want to define those? And how do we go about it?
Hey, Jamie, this is Cindy. Kind of getting back to that last question, you said it would be easy to tease out, what was the reason for the cumulative impact score's final result. Is that, by teasing that out, you mean we'd have to go to the model builder model and look at all the inputs and see what got added together to figure out what the inputs were?
Yeah. It's discrete data layers that get created in part of the model, and so you could be able to trace those back. There's not a really good tracking system for it in a tabular format. I think it'd be awfully messy to kind of identify, but we might be able to look into that, just to tag what hawks are being influenced by what change agents. Yeah, we might be able to.
So in the model,
excuse me, sorry. Go ahead.
So in the model, were any of the different input layers, was there map, algebra and math applied to it, like different formulas, or were they all just taken independently and added together?
Yeah, they were taken independently with those thresholds identified, so there's just a little bit of math algebra there. Okay. And then summed up.
Okay, thanks.
Is it possible to produce maps of each of those separate layers? Each of the drivers?
Yeah, absolutely.
Because that might be useful, to have a map that's showing the permafrost thaw impacts. And I know some of those things are going to appear elsewhere in the document, but it might be nice to have that all kind of assembled right there, so you could take a glance at it and say, oh, look, this Galena area is pretty strongly affected by permafrost thaw or temperature change or whatnot.
Yeah, no, that's a good point. We could definitely do that.
Go back to the list of things that the cumulative impact.
The big one? That's the only place where they're all listed, but.
So go to the next one, and go to the next one. Okay, so landscape condition is mostly human impact, right?
Yep, exactly.
Okay, and how is invasive species vulnerability determined? How is that determined?
That was the classification tree analysis where we looked at what climate and anthropogenic and environmental variables are associated with weedy places.
Okay. Okay. Because the other thing I was wondering is if the first, because when you add in landscape conditions, then we're kind of adding in things that we have control of a little bit more. You know what I mean? Whereas the first five are things that are driving us versus us driving them, right?
Yeah.
So I also think it would be interesting to see those first five that are the things that are driving us, that we need to react to versus the things that we can make management decisions about, like how are our decisions going to change the landscape condition versus how are the things that we don't have control of going to affect us. You know what I mean?
Yeah, it's a good point. Yeah, so we could pretty easily tease out the sort of abiotic change agent, cumulative impacts from abiotic factors, and then look at the anthropogenic.
That would be really easy to rerun this.
The reason I think that might be interesting for us is because those huts that look like they're most affected by the things we don't have control of might be the ones we need to think hardest about what management actions we should or shouldn't be taking, both proactive and authorization-wise. You know what I'm saying?
Right, absolutely.
And I just think including the landscape condition is helpful for that map, but I think for our management decision-making, it might be helpful to see it without that piece.
Yeah, that's really good. Yeah, no, that's a really good point. Kind of differentiating the management response.
Right. And that's why I was wondering about the invasive species, being that's included or not, it's a little bit of a hybrid, right?
Right,
Because,
exactly.
so maybe not, maybe it is those abiotics would be interesting to see without the rest, maybe?
Yeah.
I don't know.
Yeah.
Does anyone else think that makes sense? Yeah. I do, yeah. Okay.
And this was run at the fifth puck level?
Yeah, fifth level hucks, right.
Is Matt Varner still on? Do you know what level he's running the
Six.
watershed? Six.
Yeah.
His prioritization.
Right.
You're familiar with that?
Yeah, vaguely, I have to be right, yeah. I think you were telling me a little bit about it, and I know Becky Chaptel, our aquatic ecologist at the beginning of the, project, was working closely with them, because we were trying to develop a separate ecological integrity for aquatic systems, because they actually have this index of biological integrity. They're way further than we are in the terrestrial world and understanding ecosystem dynamics in the aquatic world. So we're hoping to develop something similar for the YKL, but yeah, the science and his modeling efforts just weren't far enough along to make it a realistic outcome for this REA. But yeah, I know, and it should be really great to mosaic the two together, really, look at them in concert.
It's hierarchical, so.
Exactly,
it's a little
it
more
should net,
complicated.
yeah.
But hopefully we can still do something with the six.
Yeah, exactly,
I guess aggregate it up to the.
right.
Question maybe for the doctor. If you were able to develop this with the economic index, do you think you could, maybe for another REA or some surrogate or proxy, do you think you could feed it into some kind of cumulative impact model so you could get a sense of, the health of the communities in addition to the, the abiotic and then the kind of negative human impact? Just wondering if that would be an interesting variable to include in these models, but I don't know if there's a possibility to get there.
If there is a possibility to get there and we get there, yes, then that's possible.
Everything's
Do you have any more, like in the North Slope, maybe where there's more to get? I don't know if that will be a possibility, but I just wonder if there's a future that we can maybe.
There are two limitations we ran against in coming up with an index. One, the amount of data we have in terms of going back in history is limited. And two, the number of variables we have that are distinct, they're not highly correlated, are limited. And well, that's three. The other limitation is the amount of variability we have between these communities is very limited. Those are the three challenges we have. So, we'll see.
It would be fascinating if there was a way to, if we could effectively map community vulnerability or community impact, and then say, is there a relationship between hucks that we think are degraded or vulnerable and communities that are.
Right.
Well, actually, ANTHC is doing their community indexing for climate change, in particular, Mike Brubaker. And I don't think he's working in this area. I think he's working up on the slope and maybe on some more coastal communities. But I'm sure that if somebody were to approach him and had a little bit of funding, he might be able to take his model and use it.
Yeah.
I'm not exactly sure.
But he's running, here's places of likely climate change where communities would likely be vulnerable. What I'm wondering is, can we say, ignoring all those things, what communities are vulnerable, and then see, does there seem to be a correlation? Exactly.
Yeah, so I've
You know what I'm saying?
Yeah, so I've actually done those models in Australia where we looked at social vulnerability, and then compared that to climate change events or other kind of landscape change factors and combine the two. So yeah, you look just purely socially, but it requires a pretty rich data set. The Aussies ask them 150 questions in their census, you know? So, we have, 3 or 4, whatever now, so, so you can get at those things a lot easier. You can come up with proxies for, you know, ability to get up and move, or, you know, have an income, or ability to even understand English well enough to, like, leave during an evacuation notice. You can model those kinds of things, spatially, which is super cool, but it's limited up here. But DeWalker and I did, at the very beginning of this REA, ask ourselves, you know, kind of philosophically, can we treat human communities as CEs and assess the impacts to the communities just as we are the CEs? Right. And it's an interesting question. You know, it was just a little outside of what we could do comfortably and maybe politically. But, you know, it's something that could be done with these data sets, is just to assess those communities that are most likely to kind of be harmed by these cumulative impacts or changes, and either to use them to engage those communities and say, look, we're kind of all faced with a bleak-looking future, let's work something out now, or to even remedy it, do some mitigation.
Hey, I want to jump in here on that a little bit. I'm, I guess, struggling a little bit how to articulate what I'm after here, but there's lots and lots of amazing things we could do, and we keep coming back to if we had the data, and if we had the data. And it really seems that in an awful lot of these categories, there was not a whole lot of detective work done. It was, what's the convenient data set, and let's move on. And the answer is, well, it wasn't in the data set we used. But we're getting an enormous amount of pressure to use the products of this to make decisions that affect people's lives. And if we go out there and show people in Huslia a map that says there's no subsistence caribou harvest in Huslia because it wasn't in the data set, or show people who rode the Fort Gibbon Trail in to come to the meeting transportation data set that doesn't include the Fort Gibbon Trail, or show a miner whose mine we're standing on but isn't in the ARDF data set, it wasn't in the data set isn't really a good enough answer to give us any credibility. So while I'm interested in all these possibilities, I really wish the effort that had gone into developing the potential, you know, ecological integrity map and all the things we could do had been put into really digging out those less convenient but really important data sets to start with. I think there's lots of amazing things we could do, but if we don't start with good data from the beginning, that error propagation you were talking about just gets worse and worse. So I guess that's the one thing I'm frustrated about here. It doesn't seem like there was really in-depth effort to dig out those important but less convenient data sets. It was just, we'll use DOT's data set, and that's is what it is. But when we know there's more stuff out there, and the public we have to talk to about how we use this data to make decisions affecting their lives no different than what's in the data set, we just have zero credibility.
Yeah, this is Karen. I think that's an inherent problem of using the RIA methodology in Alaska that we can't, that the RIAs can't solve for us, because the direction from DC and the funding from DC is basically to use the existing available geographically enabled data sets. So I don't disagree with you that we, you know, BLM, I think all the agencies need to work on developing better data sets, but the RIAs aren't now and never are going to be the tool to do that. We need to figure out what the critical data sets, and I think the thing that the RIAs are telling us, though, maybe is which of those data sets are the most critical, so that then we can go back and say, okay, we've identified the most critical data gaps now, let's start to go back and actually collect that data. And then I'm hoping that as we improve that data, then we can come back to the RIAs and rerun it. But I do agree that for the RMPs, this is a suite of data that then we have to overlay with other knowledge that we have or that the communities have to then inform our decision making. We can't just take this and say this is the answer. This is the first level, and then we're going to have to build on that to get to the RMP.
I agree with that, but my fear is when we get to this point of here's a map of ecological integrity, we're 7 steps down the road and we've forgotten about all that didn't go into it. So it just worries me that we're so focused on the complex result of model after model after model and then forgetting about what goes behind it.
Right, I think that is the biggest downside of GIS.
Yeah, you could go
Is that
an awful
gives you
lot
a
way.
certainty that doesn't
But
exist.
although we have built in, and to BLM's credit, the DC, these are all rerunnable. I mean, so really don't see the REA as an end product. It was never designed that way. It's actually the very first step in the whole landscape initiative approach. And it's absolutely just where you start. It's not a finished anything. These are just kind of teasers, and the bulk of the work was in that baseline assessment. These integrated products, this is the first REA that's done these integrated products like this. This is from DC, that they expressed distinct interest in these integrated products, so this is the first one to do it, where we really kind of put it all together and said, okay, so what? We've collected all this baseline information, what does this help us understand? And if it's that the baseline data is where we need to focus the attention, then that's a great outcome. And it doesn't degrade the fact that we have this ability to model ecological integrity or landscape condition, because as those data get updated, as we find that better data sets, it's really easy to rerun them. I mean, I can't emphasize that enough. It's going to be so easy for you guys to rerun these models, because the NOC is making sure that it's going to be easy for you to rerun these models. Trust us, we've devoted like 6 months of our time figuring out how to deliver model builder models within ArcGIS that it'll run on their servers, that you guys can run all these analyses as the data gets updated. So this is just the starting point. This is not a finished product.
So BLM, other agencies, other users get to decide what is useful for you to use. You don't have to just use what they've been presenting here for the integrated. Use what's useful at this time and then build on that. Walker's been trying to say something.
Of course. Well, no, I'm sorry. I just want to respond to Tim's comment and comments following is, I agree that we don't have the best available data, and we are running with what's available, and most of that has to do with the limitations that come with REA projects. We cannot spend any time trying to build data sets that don't exist in a format that we can use within the confines of REA. And that's why the message about data gaps is just as important as the message about available data. And as Jamie was saying, models can be rerun, and that's the whole point of having a model instead of just presenting final products. Models can be rerun with updated data, more current data. And just as an example, ARDF file is the best available data set, and even that we thought quite a few times to not use it because of the limitations that are explained in the report. Every variable in there has so many values that are not consistent, and but still that's the best we could get. So that's just an example. So is with the roads. We struggle with roads.
DOT, we looked at every possible data set we could get our hands on. We dug really deep, and we did extremely high resolution comparison in QA/QC. DOT was just as good as the other ones.
Right.
We got an Esri data set that was off that couldn't fit the projection information. We got
guys,
the same. So,
hey, this is Travis. Real quick, could somebody give me some background? Who was the gentleman that was making that comment?
Which comment? The frustration about not having the data sets thoroughly
You bet.
investigated?
Yes, sir, you. Right.
Tim Hammond. I'm the Central Yukon Field Office Assistant Field Manager.
Okay, Tim, so I think what I gather is, this is Travis Habey from the BLM with the National Operations Center. And what I gather what you're saying is you have data sets that are not reflected in here in this REA. Is that correct?
I don't know if you would say we have data sets. We have knowledge of conditions on the ground.
Did you put that in? Did you put that into a form that could be utilized by anyone outside of you or your office, or?
Yes, in the case of mining claims, we have mentioned that they should be using mining claims in the past. Mining claims are available for download to the public from our SDMS website.
And I think there's some trail information that's available in different formats, trails and easement information. I mean, it might not be complete, but that was, you know, I can't remember, in some winter trail.
So this was a several-year project, and you offered up those data sets, and were told what?
I don't know.
What we were told from the beginning was that these RIA projects were going to dig out all of the data, dig through people's file drawers, and pull up stuff that we didn't have in a format that could be used and make it usable.
Well, I don't know. I wouldn't tell you that. That's the AIM project.
Well, that's how it was sold to us to start with. But the thing that it's not just one data set. I mean, we know we manage mines that are not in the ARDF data set.
Why aren't they in the ARDF data set?
I have no idea. I don't know how it gets in there. That's not part of our role. We manage the surface of the mine. We just know they're not in there.
Well, then I think what maybe this is an opportunity to figure out why they're not in there and how they get in there, and figure out how we start making sure they're in there. I don't think it's necessarily an opportunity to say, well, that since they're not in there, we can't use any of this data because it's crap. If we don't even know how it gets in there, I think maybe the first question is, how does it get in there?
No.
Why is it not there?
The ARDF data set has a very different reason for being than something like our mining claims, which is a data set of active, claims that we need to manage and do compliance on. ARDF is a repository and inventory of all known mineral deposits throughout the state.
Mm.
And I'm not denying that, there should be better crosswalking between the two data sets, but the fact is we've brought up that the mining claims data sets exist to, AKA NHP, and it still didn't get put in as part of their analysis.
Okay, so you have a mining claims data set that provides.
Can we kind of let this to rest just a few minutes, just because I think we actually did.
We did do that.
So I feel like that's being perpetuated in this discussion.
I'm sorry, I can't hear what you guys are saying, but did the BLM person say that you had a data set of mining claims that covered all ownerships in this ecoregion or close to it, and it wasn't utilized? And it's geospatial? Let me put it that way. It has to be spatial as well.
It hasn't shown up on any of these maps. Maybe I don't know, maybe we're hearing now that they used it and we just haven't seen it.
No, I think you just hit the nail on the head. It has to be a geospatial data set that's GIS ready or it doesn't count. And the people we deal with on the ground, the people we have to look in the face and say we made good decisions about how we're going to affect your lives, don't care if it's a geospatial data set that's GIS ready. They care about, they know the trail they rode on to get to the meeting isn't in the data set you used to make the decisions.
Well, I tell you what, instead of looking back, let's look forward. And let's say it's 2014, and we're going to get that into a geospatial data set, and we'd be happy to help you do that. And then you can do like Heritage just said, and because of the REAs are not an end product, you can stick that data in there, and we can rerun it.
So Walker, is the data in there?
If one of the spatial products we presented yesterday on potential placer mines uses the current claims database overlaid with the ARDF files to identify those potentials. So we do have the claims database. We used it in producing the products that we did for the REA.
It just sounds like it's incomplete.
It sounds like it's incomplete.
But I think regardless, this has been a topic of conversation for the RIAs. It was a topic of conversation for SOAR 10. It was a topic of conversation for the YKL. The fact of the matter is the RIA is not intended to be the be-all, end-all. It's a suite of information. It's only that information was available geographically, and we definitely cannot use it as the answer to all of our questions. But hopefully it provides a suite of information that we can build on, that will inform and that we can use, that is repeatable, so we can, as we improve our data, we can improve the outputs from it.
And I would apologize profusely if we ever claimed this to be a data mining exercise. I feel like that must have been somehow mistranslated, because that is one of the things we try to flag every time we're presenting, that this is not a data mining exercise. This is just our effort to do a real rapid assessment, an 18-month project. You can maybe think of how long it takes for you to develop an RMP, and, think of we're doing this whole entire project in 18 months, so all we can do is identify existing data sets. And we've, part of the REAs, what's so neat about them is we do have the AMT, we do have the tech team, which includes a whole suite of people from multiple agencies, and throughout the extent of the project, we've had time for review, and, we talk about right up front, these are the data we're intending to use, are there any additional data sets? And then we go through this step by step. Here we present our data again during the methods and then in the products meeting, and we've had a whole suite of meetings where we've been able to try to incorporate any additional data sets that are known, if they're, again, spatial and extent, and they also have to cover, the entire study area. So there are a lot of caveats to what we could actually incorporate, if it's a small area on the landscape, we probably were not able to incorporate that into our REA, but I think we did a pretty, we tried to be really transparent and work with everybody that we could to use the best data. I mean, we really strive to do that in the project.
Yeah, and I appreciate, this is Meg, the facilitator. I appreciate the frustration of looking at some of these products and seeing the limitations, but as Travis was saying, let's go forward. And those kinds of limitations should be incorporated into the final report, which still needs to be finalized, drafted.
Yeah. It's up for review.
And the university team has included what they perceive as their limitations, and actually I think this is very useful to hear about limitations from the perspective of the users and the managers, and those should be included, and then look at going forward so that it is, what needs to be included so that it is a more useful data set, if you will, when you go forward. But I think recognizing the limitations and recognizing the data gaps, which is exactly what folks ask for, especially the data gaps, but now we're getting into limitations, is extremely important, because when you know what you can use it for and what you can't use it for and what you need to have in order to be able to use it for certain ways, you are light years ahead of being able to figure out how to get the best data you need. So.
But I think for Travis's benefit, I think that what Tim is talking about is I would say more than 50% of BLM Alaska would say that we should not be spending $1 million per RIA on the RIAs. We should be spending $1 million, millions of dollars on basic data collection. That doesn't mean that everybody, I'm not saying that that's what we want to do. We're not saying please stop funding the RIAs. We want to keep going, but there's this massive basic data failure, lack of extremely basic data in BLM Alaska, and that really limits the utility of modeling. If we don't even know which way the water flows on the landscape, which is our current situation.
Yeah, well, I have to say 100% of the people to knock would say, let's spend our money developing basic data sets and not do another REA. We've said that since the first 4 were done. It became really obvious right away that that's what we need to be doing. It's just not, that message just isn't resonating.
Right, and that's why we are continuing to ask for and fund the RIAs, because even though the data isn't great, we're at least developing the tools that the data will feed into, and that's why we've actually asked for funding for the next one after Central Yukon, because we've gone down this path. It's more helpful to have that information for the entire landscape than not, in my view. But nonetheless, I think that's kind of where we're at, and that needs to continue to be a priority for us. And it would be, if you have any thoughts on how to make that resonate, that would be.
The other thing I wanted to say is that we still spend quite a bit of time, despite maybe how it looks to other people, but trying to develop what we think of are not only legitimate management questions, but appropriate to the data, and and then we find out, or, a lot of them get ruled out early on, but each time we try to give a set of, the kind of questions like Tim was talking about, the things that the public would want to know from us or that we're concerned about, and frame them in a way that the information could either be used, or early on you could tell, you can't answer that question, but it's the same ones, each time you can more or less, in different ways answer the same set of questions. So like Karen said, I guess it is what it is, but in terms of moving forward and trying to make it better, that list of the data gaps and everything, much of which we knew early on in the process, I think we should have some internal dialogue on how to focus on getting that, I guess, and not spend as much time coming up with management questions that can't be answered, and unfortunately it is very expensive.
Well, maybe another piece of what needs to be considered here is that the existing data is incomplete, and that's really the issue. The data sets were there, but there's glaring errors in them, glaring omissions that are going to be really, really important to the public who are depending on the decisions we make. So that's not necessarily a data gap, it's a data quality issue. But we're still moving forward and taking those data sets with huge omissions forward into complex models, and that's what the public's going to see at the end. But I'm not going to go sit in Huslia and tell the elders there, we used a map that says there's no caribou harvest out of Huslia for anything. I'm just not going to do it. And I'm not going to tell my staff, quit doing your job and start instead building spatial data sets so the RIA can work well. I mean, those two things just can't happen. But at the same time, we're being told we have to use these products, not because we believe they're good, not because they use good data, not because we've checked them out and verified that we trust them, but because they have a RIA tag on them.
Okay, this is Meg, the facilitator. I'm just going to say there sounds like there needs to be some discussion internally with BLM about how to use these and when it's appropriate and when you need to augment your information. And, anything that the university can do to help, I guess, clarify that conversation, I think that they're willing to do. I'm going to say, in the interest of time, we're going to wrap up. But, and the frustration is not something I think that was unexpected, because sometimes that happens. But I think that there is some useful data here, some useful ways to use the data, and I think BLM still has quite a bit of work to do internally to figure out how to use it, and since the final products haven't been conveyed to BLM, that's still something in process about how to make it as effective as possible. With that, I'm going to move on